What's up, everybody? Today we're going to be working through this problem on the collective risk model and a special what's going on to Professor Walsh and the peer reviewers, all of which I know have to watch this video. So here's an elephant to thank you guys for your time. Now, getting on with the problem, let's define some notation. N is the number of claims made, and its distribution is given above. So N represents the total number of losses, which satisfies our first requirement from the notes we have about the collective risk model. If we can show that all four of those things work, we can apply our collective risk model and use this shortcut for the variance. Next, xi denotes the size of individual loss I. And that satisfies our first requirement up there. Next, we're also given that all the losses follow a 2 Pareto distribution with alpha equals 5 and theta equals 1200 and are independent of each other. So they're IID. That checks off this one. And we're also given xi's and n are independent from up here, which checks off all four of our requirements. Everything works nicely, and we can apply this formula for the variance. So now that we have a roadmap of how we're going to solve this problem, let's work through it. First, we need the expected value of n, which is the sum of the products of all the values and their associated probabilities. So 0 has probability 0.4, 1 has probability 0.3, 2 has probability 0.2, 3 has probability 0.1. Value times its probability, value times its probability, and so on and so forth, and what have you. That comes out to 1. Now, the variance of n is defined as the expected value of the squared difference between all of n and its mean, which is 1. So it's the expected value of the square of n minus 1. So 0 minus 1 squared has probability 0.4. 1 minus 1 squared has probability 0.3. 2 minus 1 squared has probability 0.2. And 3 minus 1 squared has probability 0.1. Again, value, probability, but this time the values are of n minus 1 all squared. And that again comes out to 1 in the calculator. Now finally, we're going to find the expected value of x and square it. That's the next piece that's required here. From our tables, we have this expression for the expected value of x to the k, and we'll just say x to the 1. So we're going to have all of this squared, and all of this being theta to the 1 factorial, divided by alpha minus 1, all squared, which comes out to 1200 over 5 minus 1, all squared, which comes out to 90,000. Now we need the second raw moment of x, which we'll later use to calculate the variance, which gives us this last piece. The second raw moment is given as theta to the second times 2 factorial over alpha minus 1 times alpha minus 2. In our case, that's 1200 squared times 2 over 5 minus 1 times 5 minus 2, which comes out to 240,000. Then the variance of x is just this minus this. Second raw moment minus first raw moment squared, which is 240,000 minus 90,000. So finally, let's put all this together. Variance of s is the expected value of n times the variance of x plus the variance of n times the square of the expected value of x. Plugging in our values, we get 1 times 240,000 minus 90,000 plus 1 times 90,000. Those ones, we can just eliminate them, and we get 240,000 minus 90,000 plus 90,000, which just comes out to 240,000. And that's our final answer. I hope this helps, and to Professor Walsh and the peer reviewers, I hope you all have a wonderful time, and I hope to see you in the Canvas discussion thread soon. Cheers.